Okay, so 5.9, we are going to do word problems. How we solve these problems is exactly the same as what we were just doing, but now they're word problems. Okay, these are called work word problems. And I'll read you the example first, and then I'll explain to you what we need to do so that you know what I mean. Okay, hold on. So for the first example, Max can wash a car in 60 minutes. His sister Kayla can do the same job in 30 minutes. How long will it take if they work together? That's what we need to find out. Okay? Now, for these work problems, we have a formula that we're going to follow every single time. Okay? We're going to take, and I'm going to write this at the top of my notes, so whatever you're doing, write this at the top right now so you don't miss it. We're going to take the together time, so however long it takes them to do it together, and you divide that by individual time. Okay? So however long it takes them to do together, divided by one individual's time, plus the together time, divided by the other individual's time. Okay? So for example 1, we don't know how long it takes them to work together, so that's our variable, so we're going to put a variable up here. Okay? We know that Max can wash in 60 minutes, so that first one goes under 60. His sister Kayla can do it in 30, so for the second one we put it over 30. But all of that equals one completed job. And we're going to use this formula for every single one. Okay? So I'll give you a minute or so to finish writing down the problem. How long does it take them to do it together? We don't know yet. It does not. Think about it, guys. If Max can wash it in 60 minutes, his sister can wash it in 30 minutes. So if they did it together, they have to do it in at least how much time? 30 minutes. But even if Max just washes a tire, that's still part of it that Kayla doesn't have to do, right? So it's actually going to be faster than her time, which is 30 minutes. Okay? So, let's look at this. Okay, do we know how long it takes if they work together? No, so that's our variable. That's what we're trying to figure out. So let's set a variable for it. What do you want to do? X? Okay, so X is the together time. So we have X over one individual's job, so 60. Plus, together time, we don't know what it is. X over 30. All of that's going to equal 1. It always equals one completed job. 1 is for when we put it together, they finish one car, right? Okay? How do I solve this? I need to get rid of the fractions. So I need to multiply everything by the LCD. What's the LCD here? 60. So multiply this guy by 60, multiply this guy by 60, and multiply that guy by 60. Okay? And what do I get? 60 and 60 cancel, so I'm left with X plus 30 goes into 60 2 times. So plus 2X equals 60. Okay, let's solve for X. So X plus 2X gives me 3X equals 60. Divide both sides by 3. So I get X equals 20 minutes. So together, they can wash the car in 20 minutes. So example 2. Mr. Jager can solve a really hard math problem in 20 minutes. It takes Miss Smith 10 minutes to solve the same problem. How long will it take if they work together? Okay, guys. So we are going to use the same formula we just used. Do I know what the together time is? No, so that's going to be x. So x over 20 plus x over 10 equals 1. Always equals 1. Okay, what is my LCD here? 20. So I multiply everything by 20. Okay? So then what happens? These 20s cancel, so I'm left with x plus 10 goes into 20 twice, so plus 2x equals 20. Okay, x plus 2x gives me 3x, which equals 20. And then what do? Divide by 3. So I get x equals 20 divided by 3. Okay, so what does that give me if I actually do the division? Okay, in these problems you might get this. So what you would do is you would round to the nearest minute. So what would that be? About 7 minutes. Okay. 3 goes into 20. 6 times 2. So it will be 6.2. What? It's 6.2626262626. So it's actually about 6 minutes. This is closer to 6 than 7. Oh, duh, 7. What was I thinking? You guys are right. Okay. Example 3. Harry can make a sleeping potion in 55 minutes. If Harry and Hermione work together, they can finish in 20 minutes. How long would it take Hermione alone? Okay, so this one is a little bit different. Do we know the together time? We do. The together time is 25 minutes. What don't we know? Hermione's time. So her time is going to be the x this time. So we have together time, which is 25, over Harry's time, which is 55, plus together time, 25, over Hermione's time, which is x. All of that equals 1 completed potion. Okay. So what is the LCD in this case? Good, 55x. So let's multiply it all by 55x. Okay. So 55 and 55 cancel. So we're left with 25x. Yes. Okay. X and x cancel. So 25 times 55. What does that give me?
A big number.
Okay, so plus 1,375 equals 55x. Okay, now I need to solve for x, so what should I do? Subtract 25x. So we get 1,375 equals 30x. So divide by 30. Okay, so if you divide this, you get x equals 45.8, which is about 46 minutes. Okay. You subtract 25x from both sides. 55x minus 25x is 30x. Okay, example 4. Rudolph can fly Santa's sleigh from the North Pole to Rayburn and back in 20 hours. If he and Dasher fly the sleigh together, they can be back in 12 hours. How long does it take Dasher alone? Okay, so I got 12 was the together time, over 20, that's Rudolph's time, plus 12 over x, x is Dasher's time, all of that equals 1 job. The LCD was 20x, so I multiply everything by 20x. 20 and 20 cancel, so that gave me 12x. X and x cancel, so 12 times 20 gives me 240. Equals 20x. And I need to get all x's on one side, so I subtract 12x from both sides. And that gives me 240 equals 8x. So I divided both sides by 8, and I got 30 hours.